All right, today we're going to dive into a programming concept that's, well, pretty much hiding in plain sight all around you. It's the two-dimensional array. Now, I know that sounds super technical, but I promise by the end of this, you'll see it's just a really smart, simple way to organize information. So let's kick things off with a quick question. Just think about it for a second. A spreadsheet you use for work, a game of chess, or even that photo you just snapped on your phone. On the surface, they feel like completely different things, right? But from a data point of view, they all share this one core organizing idea. Any guesses? That's the secret. They all use a grid, a structure made of rows and columns to keep everything locked into its proper place. This grid-like thinking is absolutely everywhere in our digital world. And, computers need a special way to handle it. And that, my friends, is exactly where two-dimensional arrays come into play. To really wrap our heads around what a 2D array is, we're actually going to start with a concept you're probably already pretty comfortable with, the good old one-dimensional array. A one-dimensional array is, at its heart, just a list. That's it. Think of it as a single straight line of items, kind of like books on a shelf or a to-do list. You've got one item right after another, and each one has its own position, or what we call an index, in that line. Super simple, super clean, and it's perfect for data that just goes in a straight line. But what if your data isn't that simple? What if it's not just one line? Imagine you have a list of high scores for Monday, and then another list for Tuesday, and a whole other list for Wednesday. Now you've got to organize these lists of lists. How would you even begin to do that? And that question right there brings us to the big idea. We're going to take those simple lists and just stack them on top of each other. And by doing that, we're going to build something way more powerful, a grid. So here's the key takeaway. A two-dimensional array, or 2D array for short, is really nothing more than a table. It's got rows, which are basically our single-lined lists, but now it also has columns, which is what creates that grid structure. It's the absolute perfect way to organize those lists of lists we were just talking about. Check this out. Here's a perfect example. A table we'll just call my table. As you can see, it's a grid with 10 rows and 3 columns, and every single cell is holding a number. Now, to find any value in here, we need its coordinates, right? And here's a super important detail in programming. We almost always start counting from 0. So that means the rows are numbered 0 through 9, and the columns are 0, 1, and 2. Okay, so seeing it as a table is great for us. It makes sense in our brains. But how do we actually tell a computer to create one of these? Let's switch over to the code and see how it's actually built. So different programming languages have their own little quirks for saying the same thing. Pseudocode, for example, is super descriptive. It lets us declare an array called myTable and spell out the exact ranges for the rows and columns. Python and Java, on the other hand, are a bit more visual. We literally create a list of lists. See how each inner list, like 27, 31, 17, is just one row in our grid? You can almost see the table right there in the code. Okay, so we've built our grid, we filled it up with data. Awesome. The next essential skill is knowing how to pull a specific piece of data back out. I mean, how do we pinpoint one exact value in this whole sea of numbers? Let's give ourselves a little mission, using our myTable example. We need to find the value that's located at myTable 2, 1. And remember what those numbers are. They're the coordinates. The first number is always the row, and the second one is the column. Honestly, the best way to think about this is like finding your seat in a movie theater. It's a really simple two-step process, right? First, you look at your ticket and you find the correct row. And once you're standing in the right row, you just walk along until you find your seat number. That is exactly how we navigate a 2D array. So for our task, myTable 2, 1, we start with that first number, the 2. That's our row index. Now, because we start counting from 0, index 2 is actually the third row down. Okay, now that we're on the right row, we look at the second number, which is 1. That's our column index. So we just move across to the second column. And the value sitting right there at that intersection is 98. See? It really is that simple. Once you have the coordinates, you can instantly grab any piece of data you want from the grid. It's just an incredibly efficient way to store and retrieve information. Now, I know this all might still seem a bit abstract, maybe like a pure programming exercise, but the reason this matters so much is that 2D arrays are the silent workhorses behind countless apps and programs you use every single day. Let's connect this to the real world. A spreadsheet is the most obvious one, right? It's literally a giant 2D array that you can click on.
A chessboard? That's just an 8x8 grid, perfect for a 2D array. But what about a digital image? It's just a massive 2D array of pixels, where each little element in the array stores a color value. From the seating chart for an airplane to the very structure of databases, this simple grid is absolutely everywhere.
So the next time you're looking at your calendar, or playing a video game, or zooming in on a map, just take a second to look for the grid. Because now that you know the structure, you'll start seeing how so much of our digital world is built on this powerful yet simple idea of rows and columns. So what other examples can you think of? Something to chew on. Thanks for tuning in.